Hello, today I'm going to be showing you the mole and how it's used. In chemistry, we use a unit of measurement called mole, also spelled mol, M-O-L. The mole is used for measuring massive quantities of very small entities, such as atoms, molecules, or other particles. The number used for this is 6.02214,076 times 10 to the 23rd. This is known as Avogadro's number, named after Amedeo Avogadro. This can also be known as Avogadro's constant. The number of atoms or other particles in a mole is the same for all substances. The concept of molarity is really useful. The mole is used to determine the simplest formula of a compound and to calculate the quantities involved in a chemical reaction. Molarity is defined as the number of moles of a solute in a liter of solution. The mole is one of the 7 base units in the International System of Units. Units are typically invented when existing ones are simply not good enough. Chemical reactions often take place at levels where using grams would not make any sense, yet using absolute numbers such as atoms, molecules, or ions would be confusing as well. Compare moles to a dozen eggs, which is 12. A gross is 144, and if you're familiar with bytes, it's 8 bits. However, Avogadro's number is 6.022 times 10 to the 23rd power. The most common conversion is moles to grams. When balancing equations, the mole ratio between reactants and reagents is used. All you really need is a periodic table. When you get your periodic table, make sure that you use the ones that have the mass at the very bottom. Not the number at the top left, but below the actual name. The different types of mole conversions are converting from mass to moles to mass, volume to moles to volume, particles to moles to particles, and mole to mole. Another of the most common conversions are mass to moles, volume to moles, particles to moles, and moles to moles. For each of these, mass to moles, you divide the initial mass by the molar mass of the compound as determined by the periodic table. For moles to mass, you simply multiply. For volume to moles, you divide the initial volume by the molar volume constant, and for moles to volume, you simply multiply. For particles to moles, you divide your particle value by Avogadro's number, and for moles to particles, you simply multiply. For mole to mole, you use the coefficient from your balanced equation to determine your conversion factor. Now I'm going to show you an example. How many moles of carbon atoms are present in 30 grams of carbon? Well, let me show you. First, you need to figure out the carbon atomic mass, and if you look at your periodic table, you'll see that that's 12 AMU. To set up your equation, make sure you start with what you have. You know that it's 30 grams of carbon over 1. You multiply that over 1 mole of carbon over 12 grams of carbon. Make sure that when you set it up, you have it to where you can cancel out the conversions. That will lead you to 2.5 moles. What I like to do personally so that I don't get confused is that I rewrite it, and at the end I carry over the 30 over the 12 so that I don't get confused. That is still 2.5 moles. The same can go for liters to moles and for atoms to moles. The mole is important because it allows chemists to work with the subatomic world of macro world units and amounts. Atoms, molecules, and formula units are really, really small and often really hard to work with. However, the mole allows the chemists to work with amounts large enough to use. The mole of something, as we remember, represents 6.022 times 10 to the 23rd items or particles. Whether it be an atom, molecule, or formula unit, defining the mole in this way allows you to change grams to moles or moles to particles, even though you can't really see the particles. And that is the end.